we're done. We're just going to talk about sum and difference formulas for sine and cosine. And just a little thing so that you guys are aware, the variables I use are alpha, written this way, kind of like a Jesus fish, and beta, written like this, kind of like a funky capital B with a long tail on it. I am using those just because they're Greek letters. I tend to use Greek letters to represent angles, and in this section they're going to represent angles the whole time. So the sum formulas. Again, we're only going to talk about sine and cosine. The sine of alpha plus beta is sine of alpha cosine of beta plus sine of beta cosine of alpha. The formula for cosine of alpha plus beta is cosine of alpha cosine of beta minus sine of alpha sine of beta. So there are the difference formulas. Same exact thing as the sum formulas, but these are switched around. To find the exact value for the sine of 75 degrees. Exact means not a decimal, because a decimal you're going to have to round, and when you have to round it, that is by definition an approximation. So what we want to do is rewrite this in terms of sine of alpha plus beta, where alpha and beta are two angles that we know the exact values for. So what two angles that we know exact values for add up to 75? This is the sine of 30 plus 45. It's addition, so it doesn't matter which order they're in. Using our formulas, this is sine of 30 cosine of 45 plus sine of 45 cosine of 30. This is where we have to remember the unit circles. Sine of 30 is 1/2. Cosine of 45 is root 2 over 2. Sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. So we have root 2 over 4 plus root 6 over 4, which we can combine into one fraction as root 2 plus root 6 all over 4. The nice part is that these answers are always going to be some combination of root 2 or negative root 2, root 6 or negative root 6, all over 4. We have to do the same idea here. This is going to be the cosine of, we could do 150 plus 45. That is by no means the only way to do this. You need two angles that you know exact values for that add up to 195. So you could do 135 plus 60. It doesn't matter which two, so long as they are angles that you know exact values for. By our formula, we know this is going to be cosine of 150 cosine of 45 minus sine of 150 sine of 45. Moving through here, we've got cosine of 150 is negative root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 150 is 1/2. Sine of 45 is root 2 over 2. So we've got negative root 6 over 4 minus root 2 over 4, which is negative root 6 minus root 2 all over 4. So again, your answers are always going to have a denominator of 4 and be some combination of root 6, root 2, where the positive, negative signs could switch as well. So up here, what we've got is we could say this is sine of pi over 4 minus pi over 6. If we have subtraction of two fractions, which means you need a common denominator, that common denominator will be 12. This is 3 pi over 12. This is 2 pi over 12. 3 pi over 12 minus 2 pi over 12 is 1 pi over 12. Using our formula, we've got sine of pi over 4, cosine of pi over 6, minus sine of pi over 6, cosine of pi over 4. Go through. The sine of pi over 4 is root 2 over 2. The cosine of pi over 6 is root 3 over 2. Minus the sine of pi over 6, which is 1/2, times the cosine of pi over 4, which is root 2 over 2. So we get root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 all over 4. So we need two angles that make 11 pi over 12. Let's try 2 pi over 3, pi over 4. This is going to be 8 pi over 12. This is going to be 3 pi over 12. 8 plus 3 is 11. So, cosine of 2 pi over 3, cosine of pi over 4, minus sine of 2 pi over 3, sine of pi over 4. Cosine of 2 pi over 3 is negative 1/2. Cosine of pi over 4 is root 2 over 2, minus sine of 2 pi over 3, which is root 3 over 2. Sine of pi over 4 is root 2 over 2, so we get negative root 2 over 4, minus root 6 over 4, giving us negative root 2 minus root 6 all over